Welcome to our deep dive. And this one's especially for all you relational database experts out there. We know you're already familiar with the basics, so we're going to skip right ahead to the good stuff. Why is Hadoop making waves in the database world? What's all the hype about?
You know, it's pretty fascinating. Hadoop can handle these huge challenges that traditional databases just weren't built for. Think about all the data that's out there now. Social media, sensor networks, even scientific research. It's incredible. And relational databases, they kind of struggle with this, with their structured schemas and all that emphasis on ACD properties.
Yeah, it's like trying to squeeze a whole ocean into a little teacup.
Yeah.
So where does Hadoop fit in? What makes it so unique?
Hadoop takes a totally different approach. Instead of a strict schema up front, it uses schema on read.
So the data structure is defined when it's being processed, not when it's stored initially.
Right.
That's pretty flexible. But what about consistency? ACD properties are a big deal in relational databases.
Absolutely. And Hadoop doesn't totally ditch those principles, but it focuses on different things. It uses the base principles. Basically, available, soft state, and eventually consistent.
So consistency might not be immediate, but the system stays up and running even with huge data sets and complex processing tasks. It's like a trade-off, right? When would you actually want to go with that kind of approach?
It's really useful when you've got those massive data sets that would just overwhelm a traditional database. Like if you're analyzing website clickstream data to understand user behavior or combining all sorts of different data sources to detect fraud, maybe even predicting risk across entire industries. Hadoop really excels in those situations. It lets you analyze all of your data, not just a little sample.
It sounds like Hadoop could be a real game changer, especially for organizations struggling with the limitations of traditional databases. But let's talk about practicalities. What kind of operational and cost challenges does Hadoop address?
One major challenge is the cost of scaling those traditional databases to handle these huge data sets. You need expensive, specialized hardware, and that can get really expensive fast. But Hadoop's different. It's designed to run on clusters of commodity hardware, so it's much more cost-effective to scale up your processing power.
So instead of investing in some giant supercomputer, you can distribute the workload across more affordable machines. That's pretty clever. Are there any other operational advantages?
Definitely. Hadoop is really good at handling unstructured and semi-structured data, things like social media posts, censored data text documents, and traditional relational databases, they have trouble with that. All that emphasis on structured tables and schemas makes it difficult to work with.
Yeah, it's like trying to put a square peg in a round hole.
Yeah.
So Hadoop opens up all these new possibilities for analyzing data that used to be really difficult or even impossible to work with. But how do you actually use this data in Hadoop? What kind of tools are available?
That's where the Hadoop ecosystem comes in. It's a whole set of tools and components designed to store, process, and analyze data in this distributed environment. One of the core components is HDFS, the Hadoop Distributed File System. That's where all the data is stored, spread out across multiple nodes for redundancy and scalability.
It's like a giant distributed hard drive capable of storing petabytes of data.
Wow.
But what about processing all that data?
That's where MapReduce steps in. It's a programming model that divides those complex tasks into smaller parallel operations that can be run across the entire cluster.
It's like having an army of chefs, each working on a small part of a giant feast. Make sure the meal's ready efficiently and on time.
That's a great analogy. But Hadoop can be kind of complex to work with. Are there any tools that make it more accessible for people who aren't hardcore programmers?
Oh, absolutely. Tools like Pig, a high-level scripting language that simplifies those MapReduce jobs. And then there's Hive, which gives you a SQL-like interface to Hadoop, so anyone familiar with relational databases can query and analyze data pretty easily. So Hive is like a translator in our kitchen analogy. It lets us talk to the chefs using a language we actually understand. I like that.
Right. And then we have HBase, a NoSQL database that's built right on top of Hadoop. Perfect for handling those sparse distributed data sets. Imagine tracking real-time data from thousands of devices. HBase can handle that without breaking a sweat.
Wow. It sounds like the Hadoop ecosystem has a lot to offer. But I'm sure there's some potential downsides too, right? What kind of challenges might organizations face if they decide to go with Hadoop?
Well, performance can be a challenge, especially with HBase. You have major compactions that are needed to keep things running smoothly, but they can slow the system down temporarily. It's a bit like having to reorganize your whole garage just to find a single screwdriver. Necessary, but not always convenient.
Right. Performance is always a balancing act. Any other things to consider?
Cluster sizing and configuration are also really important. Choosing the right hardware, configuring the network correctly, and understanding the costs involved, whether it's on-premise in the cloud or a hybrid setup. All of that needs to be carefully considered.
Sounds like implementing Hadoop successfully takes a lot of planning and a deep understanding of both the tech and the data itself.
You got it. And we haven't even touched on security data governance or the challenge of finding people who know how to manage a Hadoop cluster. But despite all that, the benefits of Hadoop are hard to ignore. It's a powerful platform that's changing how organizations collect, process, and analyze data.
And in our next deep dive, we'll take a closer look at those challenges and talk about some strategies for overcoming them. Stay tuned.
We've been talking a lot about the technical side of Hadoop, but it's important to remember the bigger picture, right? Why is Hadoop so important in the world of databases today?
That's a really good point. It's easy to get lost in all the details, but ultimately it's about solving real-world problems, right?
Exactly. The amount of data being generated is just exploding, and those traditional relational databases are having trouble keeping up. Hadoop, with its scalability, its flexibility, and its ability to handle unstructured data, it's filling a critical gap.
It's like the Swiss Army knife of big data.
No.
There's a tool for every situation.
Okay.
But can you give us some specific examples of how organizations are actually using Hadoop to solve these real-world problems?
Of course. One area where Hadoop is having a huge impact is data warehousing. Companies are using it to build these massive data lakes where they can store all kinds of data, structured, semi-structured, unstructured, you name it. This allows them to analyze data that was previously siloed or even ignored, and that leads to new insights and better decisions.
So instead of having all these separate databases for things like customer data sales, data web analytics,
Yeah.
they can bring it all together in one place.
Exactly. And because Hadoop is so scalable and cost-effective, they can store and analyze much larger data sets than they ever could with traditional data warehouses. They get a more complete picture of their business and make more informed decisions.
That makes a lot of sense. What other use cases are out there?
Fraud detection is another area where Hadoop is really shining. By analyzing these massive data sets of financial transactions, Hadoop can spot patterns and anomalies that might indicate fraudulent activity. This helps banks and other financial institutions to prevent fraud and protect their customers.
It's like having a whole army of digital detectives constantly on the lookout for suspicious behavior. I bet that's incredibly valuable.
It really is. And since Hadoop can work with real-time data streams, it can even detect fraud as it's happening.
Wow, that's impressive. Any other examples you can share?
Sure. In healthcare, Hadoop's being used to analyze patient records, medical images, even genomic data to improve diagnoses, develop new treatments, and provide more personalized patient care.
It sounds like Hadoop is really pushing the boundaries of what's possible with data analysis.
It is, and these are just a few examples. There are countless ways that Hadoop is being used across industries to solve all sorts of problems.
Okay, so we've talked about why Hadoop is important, and we've seen some really interesting use cases. But we also talk about some potential downsides, right?
Right. Hadoop offers some amazing benefits, but it's not a silver bullet. Implementing and managing a Hadoop cluster can be really complex and challenging.
So let's dig into some of those challenges. What are some of the biggest hurdles that organizations might encounter?
Well, one of the biggest challenges is finding people with the right skills to work with Hadoop. It's still a relatively new technology, so the demand for Hadoop expertise is much higher than the supply. Companies often have a really hard time finding qualified candidates to build and manage their Hadoop clusters.
It's like trying to find a needle in a haystack, a really valuable and specialized needle. What can organizations do to address this skills gap?
They can invest in training and certification programs for their current employees. They can partner with universities and other schools to develop a pipeline of Hadoop talent. And of course, they can try to attract experienced Hadoop professionals from other companies by offering competitive salaries and benefits.
Those are all good options.
Right.
What other challenges come to mind?
Data governance is another big one. Hadoop's flexible schema and ability to handle unstructured data mean it's really important to have strong data governance processes in place. You need to ensure data quality, consistency, and security.
So it's not just about collecting and storing the data. It's about managing it properly and making sure it's reliable and trustworthy.
Absolutely. And this can be really tricky in a distributed environment like Hadoop, where data is spread out across all those nodes.
Right. So what are some of the best practices for data governance in Hadoop?
Well, it all starts with clearly defining roles and responsibilities for data ownership. You also need to set data quality standards and implement processes for data cleansing, validation, and enrichment. And of course, you absolutely have to make sure sensitive data is properly secured and protected.
It sounds like data governance is an ongoing process, not just something you set up once and forget about.
Exactly. It requires constant monitoring, adaptation, and improvement to keep up with the changing data landscape and all those evolving regulations.
Okay, so we've covered skills and data governance. What other potential pitfalls should we watch out for?
Well, security is always a major concern with any data system, but it's especially critical with Hadoop. It's a distributed system, and it often handles really sensitive data, so you have to be extra careful. Securing a Hadoop cluster requires a multi-layered approach, including authentication, authorization, encryption, network security, and auditing.
Sounds pretty complex.
It is, and you can't afford to take it lightly. A security breach in a Hadoop cluster could be devastating for an organization.
That's a scary thought. So what advice would you give to organizations that are thinking about implementing Hadoop or maybe already using it?
The most important thing is to take security very seriously. Invest in the right security tools and make sure you have the expertise to use them properly. Security needs to be an integral part of all your Hadoop operations.
That's great advice. Any other words of wisdom?
Yeah, don't try to do everything at once. Start with a specific use case and build from there. Don't try to implement every Hadoop tool and technology right away. And be prepared to iterate and adapt as you learn more about Hadoop and how it can best meet your specific needs.
Those are some really helpful tips. So even though there are challenges, Hadoop has the potential to be incredibly valuable for organizations that are willing to put in the time and effort to use it strategically.
Absolutely. And as the Hadoop ecosystem continues to mature, I think we'll see even more innovative use cases and even greater value from this technology.
Speaking of the Hadoop ecosystem, let's dive a little deeper into the different components and tools that make up this fascinating world.
It really is a fascinating world. It's like a bustling marketplace where each tool offers a specialized service. And just like in a real marketplace, you need to know where to go to find what you need.
I like that analogy.
Yeah.
So where should we start our tour of the Hadoop ecosystem?
But we've already talked about HDFS and MapReduce, which are two of the core components. But there are many other tools and technologies that extend Hadoop's capabilities and make it even more powerful and versatile.
Okay, so let's take a closer look at some of these tools. What do we go first?
One really popular tool is Hive, which, like we mentioned earlier, gives you a SQL-like interface to work with Hadoop. This makes it so much easier for people who are already familiar with relational databases to query and analyze data in Hadoop.
So they don't have to learn a whole new programming language. They can use the skills they already have. That's great.
Exactly. Hive also has a number of other features that make it a valuable tool for data warehousing. Features like data partitioning, different table formats, and support for user-defined functions.
Sounds like a really useful tool for data analysts and business intelligence folks. What other tools are out there?
Pig is another one. It's a high-level scripting language that makes those MapReduce jobs simpler. Pig lets you define complex data transformations in a more concise and readable way than traditional Java code.
It's like having a translator that can take your ideas and convert them into a language that Hadoop understands.
That's a great way to put it. Pig also comes with a number of built-in functions for common data processing tasks, like filtering, sorting, grouping, and joining data sets.
It sounds like a really valuable tool for data scientists and developers who need to work with Hadoop, but don't want to get bogged down writing a lot of low-level code. Are there any other tools you want to highlight?
Sure, there's HBase, which we talked about a little bit before. It's a NoSQL database that sits on top of Hadoop, and it's designed for handling those sparse distributed data sets.
Can you quickly explain what you mean by sparse distributed data sets?
Of course. A sparse dataset is one where a lot of the values are missing or empty. For example, imagine a social media platform that has a table with users and their interests. Most users will only have a few interests listed. So you end up with a table with a lot of empty cells, and that can be really inefficient to store and query in a traditional relational database. And a distributed dataset is just one that's spread across multiple nodes in a cluster.
So HBase is designed to handle this kind of data in a way that's efficient and reliable.
Exactly. HBase is also really good at handling lots of write operations, which makes it a good choice for applications that involve real-time data ingestion and analytics.
Sounds like a valuable tool for organizations that deal with large volumes of data that's constantly changing. Are there any other tools we should know about?
Well, there are tons of other tools in the Hadoop ecosystem, but we've covered some of the most important ones. The main takeaway is that Hadoop isn't just one technology. It's a whole platform with a rich and diverse set of tools that can be used to tackle a wide range of data challenges.
It's like a toolbox with a tool for every job. But with so many tools to choose from, it can be hard to know where to start.
That's true. But like we've discussed, the best way to approach it is to start with a specific problem you want to solve, and then choose the tools that are the best fit for that problem. And don't be afraid to experiment. Try different tools and see what works best for you.
That's great advice. So we've explored the Hadoop ecosystem and seen how all the different pieces work together. But as with any technology, there are some potential downsides to be aware of.
Absolutely. Hadoop has a lot of benefits, but it's important to understand its limitations and to go into it with a realistic plan and expectations.
Okay, so let's talk about some of the pitfalls of using Hadoop. What are some things that can go wrong?
One common mistake is underestimating how complex Hadoop really is. It's a distributed system with a lot of moving parts. Setting it up, configuring it, and managing it can be quite challenging.
It's not like installing an app on your laptop.
Definitely not. It takes specialized skills and a deep understanding of how distributed systems work.
So what can organizations do to avoid this pitfall?
They need to make sure they have the right people with the necessary skills and experience. It might also be helpful to partner with experienced Hadoop consultants or vendors who can help them with the implementation.
Makes sense. Any other pitfalls we should keep in mind?
Another common trap is trying to use Hadoop for absolutely everything. Hadoop is amazing for certain types of workloads, but it's not meant to replace every other data management technology out there.
It's about choosing the right tool for the job.
Exactly. For instance, Hadoop isn't the best choice for transactional workloads or applications that need really low latency.
Right. It's all about understanding Hadoop's strengths and weaknesses and using it for the tasks it's best suited for.
You got it. It's also important to be realistic about how long it takes to implement and manage Hadoop. It's not a quick fix, and it requires ongoing attention and investment.
Organizations need to be in it for the long haul.
They do. But if they approach it with the right mindset and strategy, they can reap significant rewards.
That's a great point to remember. So even though there are potential challenges, Hadoop is still a really powerful and transformative technology. It can help organizations unlock the value hidden within their data.
I completely agree. And as the Hadoop ecosystem continues to evolve, I think we'll see even more innovation and even more benefits for those organizations that choose to embrace this technology.
We've covered a lot of ground in this deep dive into the world of Hadoop. We've looked at the key concepts, the ecosystem, the different use cases, and even the potential pitfalls. But I'm sure there are many more insights waiting to be uncovered in this fascinating field.
Absolutely. Hadoop is constantly evolving. There's always more to learn.
So as we wrap up this part of our deep dive, I want to encourage you, our listeners, to keep exploring the world of Hadoop and discover how it can help you unlock the power of your data.
And don't forget to check out the show notes for links to resources, courses, and communities where you can dive deeper into Hadoop and connect with other data enthusiasts.
That's a great tip. And until next time, stay curious, stay informed, and keep diving deep. You know, we've talked about how powerful Hadoop is. We've gone through the whole ecosystem, and we've even touched on some of the challenges. But there's one really crucial aspect that I don't think we've fully explored yet, and that's security.
You're absolutely right. Security is super important, especially when you're working with the kind of sensitive data that often ends up in a Hadoop cluster.
Exactly. Think about it. Customer information, financial records, proprietary research data, all incredibly valuable, both to the organization and to anyone who might be trying to get their hands on it illegally.
You hit the nail on the head. And because Hadoop's a distributed system with data spread out across all these different nodes, securing it is a whole different ballgame than what you'd do for a traditional centralized database.
Yeah, it's not just about locking down a single server. You've got to secure the whole network and every single point of access within the cluster.
Yeah.
Where do you even begin with something like that?
Well, the key is to take a layered approach. Address security at different levels, from the individual user all the way up to the network itself.
Like building a fortress with multiple layers of defense, right? Each one reinforcing the others.
That's a great way to think about it. One critical layer is authentication, making sure that only authorized users can even get into the system. Strong passwords, multi-factor authentication, even biometrics can all play a role.
So basically a really strong front door. But what happens once someone's inside? How do you control what they can see and do within the Hadoop cluster?
That's where authorization comes in. It's all about controlling access to specific data and actions within the system. You might have different levels of access depending on someone's role department or even their individual clearance level. Some people might only be able to view data while others have permission to edit or delete it.
So it's like a need-to-know policy.
Mm-hmm.
Even if you're authorized to be in the system, you can only access what's necessary for you to do your job.
Precisely. And then you have data encryption, protecting the data itself, both in transit between nodes and at rest on the nodes. So even if someone manages to get past the authentication and authorization, the data itself will be unreadable without the right decryption keys.
It's like even if someone gets past the guards and breaks into the vault, the treasure chest is still locked. That's reassuring. But what about the network itself? How do you protect the communication channels within the Hadoop cluster?
That's where network security comes into play. Firewalls, intrusion detection systems, secure protocols, all these things work together to prevent unauthorized access and malicious activity on the network. It's like having a moat and a drawbridge around our fortress, making it that much harder for attackers to get in.
Okay, so multiple layers of defense all working together to keep the system secure. But security is a constantly evolving challenge, right? Attackers are always finding new ways to try and break in.
You're absolutely right. Securing Hadoop isn't something you do once and then forget about it. It's an ongoing process. You need to be constantly monitoring for vulnerabilities, patching security holes, updating your defenses, and adapting to new threats as they emerge.
It's not just about building a fortress. You need a vigilant guard force constantly on the lookout for potential breaches.
Exactly. And if you're dealing with really sensitive data, it might even be worth bringing in some specialized security consultants. They can offer expert guidance and support.
That makes a lot of sense. So for someone listening who's already familiar with security best practices in relational databases, what are some key things to remember when it comes to securing Hadoop?
Well, first off, never underestimate how important security is in a Hadoop environment. It's a distributed system. It often handles very sensitive data. It's a prime target for attackers.
You're not just protecting the data itself, you're protecting the entire infrastructure and every single point of access.
Exactly. And the second thing to remember is that security is an ongoing process. It's not a one-time thing. You have to stay vigilant and adapt to new threats and constantly evolve your security posture.
Build your fortress, train your guards, and never let your guard down.
That's it. And finally, don't be afraid to ask for help. There are specialized security tools and consultants out there who can help you navigate the complexities of Hadoop security.
That's great advice. So to wrap things up, I think we've really dug deep into the world of Hadoop today.
We've covered the basics, the ecosystem that uses the challenges, and of course, the absolute necessity of strong security.
And for anyone listening who now has all this knowledge under their belt, what's the next step on their Hadoop journey?
I'd say dive into the show notes. We've got links to all sorts of resources, courses, communities where you can really explore specific areas of Hadoop that you find interesting.
That's a great point. And until next time, stay curious, stay informed, and keep diving deep.